Hi students, welcome to continued video on control system. So we were discussing Routh's array. So as I just mentioned in the description box of Routh's array 2, so there was a issue in the last problem. So this is that problem. We'll just revisit and then proceed, try to identify where the mistake is and what is that mistake is. Okay, now this was the characteristic equation what we considered in the last problem of the previous video. So it is this, and then we wrote the Routh's array by considering this as a characteristic equation. We end up with 0k0 as one of the third row of this particular array. Then since not all the elements of the row are 0, I cannot consider it as a Routh's array. We are replacing, or we are modifying the characteristic equation by replacing s by z to the power minus 1 or 1 over z. So this is nothing but 1 over z. Now this is what is the replacement of s by 1 over z, and then we found a modified characteristic equation which is having k as quotient of z to the power of 4 and other quotients are 1, 1, 1, 1, so on. So then we continued writing the Routh's array for this characteristic equation, this modified characteristic equation, and then we wrote this as k11 and then 1, 1, 0. Then we started continuing the second or the third row, which is nothing but 1 into 1 minus k into 1, which is 1. Okay, this is actually 1 minus k by 1. And for this one, actually in the previous video it was written as 0. It will not be so. Suppose if I take this 1 into 1 minus k into 0 by 1. So this is not 0, this is actually 1. Suppose if I want to rewrite that entire stuff, so let me just take that equation and then redo the entire thing. So what I have is something like this now. So we have k z to the power of 4 plus z cube plus z square plus z to the power of 1 plus, so it's actually 1 equal to 0. So I can write the Routh's array for this. It is z power 4 z cube, which is now k 1. This is what is k here, then it is 1, then it is 1, and then next it is 1, 1, 0. Z square would be 1 into 1 minus k into 1 by 1, and this is 1 into 1 minus k into 0 by 1, and it is 0. So actually this comes out to be 1 minus k, and this is 1, 0. So z square is so and so, and then let us continue the array by writing z power 1. So is it now 1 minus k into 1 minus of 1 into 1 by 1 minus k. So now this is what is the thing what you're going to have, and then next what you have is this is what it is, this into now this into this minus this into this is this, next it is this into this minus this into this, so it's actually 0, 0. So now what is this now? So you have this as, so now if I solve for this, it is 1 minus k minus of 1. So you can see 1 minus of k, 1 by 1 minus k. This will go off, so you will end up with minus k by 1 minus k. So this is what is z power 1, and it is 0, 0. And what is z power 0 now? So this is now this into this minus this into this, so by this, so this is actually 1, 0, 0. Vinit, Vinit. So this is the thing what you'll have. If I just rewrite this, z power 4, is it now k11, z cube is 110, z square is 1 minus k10, z power 1 is minus k by 1 minus k, and it is what? 0, 0, and last term is minus 0. This is what the first column is. So what the first column? Now if the value of k is, take it as 0.1. If the value of k is 0.1, do you have it as 0.1 as the first element, second element is 1, here it is 0.9, can you see it is minus 0.1 by minus 0.1 by 0.9, and it is 1. See the sign change. See, is this positive, 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 and it is negative, positive. So how many sign changes? There are 2 sign changes. There are 2 sign changes, meaning that 2 roots lie onto the right hand side of the S-plane if the value of k is what? 0.1. If k is equal to 1, if k is equal to 1, what do you have? This will be 0. If k is equal to 1, what will be this? So it is minus 1 by 0. So it is minus 1 by 0. What is this actual value? So because you are taking k is equal to 1. If k is equal to 1, this will become, okay, let me write that. This is for k equal to 1. So let us see the sign changes. So is this value 1 here? Is this value again 1? Is this value 0? What is this value here? It is minus 1 by 0. What is this value? It is 1. See, is this 1, 1, 1, minus infinity and 1? Again you see there is a negative sign. Since there is a negative sign is there on its, okay, if you see the sign change in the first column, can you see it is positive, 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 and then negative. Forget about the magnitude. See what is the sign. Sign is negative and then it's again positive. Can you see still here also there are 2 sign changes that are happening for a value of k equal to 1. Now let us take the value of k, which is maybe 10. If I take k is equal to 10, is this 10 here? Is this 1 there? Is this minus 9? So is this minus 10 by, what is this value? Is it minus 9? And then is it 1? Now again you check the sign change. Can you see this has become positive? This has become positive, but this has become negative. Can you see this is 1 minus k. Since k is 10, so this has become minus 9. Now for values of k equal to, value of k is equal to 10, you still see a 2 sign changes happening, meaning that there are 2 closed loop poles lying onto the right hand side of the S-plane. So for any value of k ranging from very small value equal to 1 and greater than 1, there are 2 sign changes happening on the first column of the Routh array. What does it mean? 2 sign changes happening in the first column of the Routh array is there are 2 closed loop poles always onto the right hand side of the S-plane irrespective of the value of k, whether it is less, of course we are taking the value of k always greater than 0. For values of k which is greater than 0, and of course this is like this. So now this is the value of k is always between 0 to infinity. Anything greater than 0 but less than infinity, you will have 2 sign changes happening on the first column as we just saw it here. So that means that this system, or typically it is actually this system, because original system is this, because from this we got this. So this system is unstable for all values of k. This is unstable for any values of k between 0 and infinity. So we call such system for any value of k greater than 0, less than infinity, if it is unstable, means this is absolutely unstable system. You cannot make the system stable at all. So this is always unstable. Hope it is clear. So of course only thing was, this was, instead of taking it as 1, by mistake we took it as 0. So that's why it ended in so many wrong conclusions. But the conclusion here is this characteristic equation ending with something like this peculiar condition, that was resolved by taking s as 1 over z, and that ended in a different characteristic equation. For this characteristic equation, when we wrote this, we had this situation. This situation says that for any value of k between 0 and infinity, there are two sign changes happening, meaning that there are two closed loop poles always on the right hand side, meaning that system is unstable. Okay, two are there on the left hand side, but since there are two on the right hand side of the S plane, system is unstable. Okay, so then we just move on to, so let us be a bit careful while just writing the Routh array. So this will happen for me as well as for you all. So now it is s power 4, it is s cube. So let me just start writing it is now 1 3 k, next it is 3 2 0, next it is s square. What is this value now? Is it not 9 minus 2 by 3? Then it is 3k minus 0 by 3, next it is 0. So this happens to be 7 by 3. So this is now 7 by 3, this is k, and then this is 0. So what is s power 1 now? So s power 1 is 7 by 3 into 2 minus 3k. Is this fine? 9? Okay, fine. This is okay. This is 7 by 3 into 2 minus 3 into k divided by 7 by 3. And how about this? This into this minus this into this minus this into this. It's actually 0, 0. Then shall we write s power 0 now? It is this into this minus this into this by this. So since you are multiplying this with 0, the negative term will be 0, and again you are dividing with this, so this will become k, 0, 0. So now have a look at the first column. So in the first column, this is positive, this is positive, this is also positive, and you have this term, and you have this term. Now if you look at this term, is it now 14 by, so this particular term, shall we take it as 7 by 3 into 2 minus 3k by 7 by 3. Shall I write it as 14 by 3 minus 3k by 7 by 3? Shall we write it as, this is now, okay. Now, so now how long this will be positive? So this will be positive as long as 3k is less than 14 by 3, correct? Or k if it is less than 14 by 9. 14 by 9. If the value of k is less than 14 by 9, do we have this as positive value? So does this will be positive? So for this to be positive, k has to be less than this. If the value of k is equal to 14 by 9, so just make sure that this k becomes 14 by 3 minus of 3 into, let us make this as 14 by 9. So does this become 3 here? So now, is it now 14 by 3 minus 14 by 3, will it actually become 0? If it becomes 0, does this term become 0? If this becomes 0, do you have 0, 0, 0 condition which is ending with the auxiliary equation? That auxiliary equation is this. So what is the auxiliary equation? If k is equal to 14 by 9, if k is equal to 14 by 9, you have an auxiliary equation which is nothing but 7 by 3 s square plus you have k. So what is that k here? So this k is 14 by 9 is equal to 0. So this has to be 14 by 9, then only it's actually what is AFS? AFS is equal to 7 by 3 s square plus k equal to 0. When this will become an auxiliary equation? Only when this is 0. Only when this is 0. When does this will become 0? When k is 14 by 9. So how you got it as 14 by 9? So you are writing this as 14 by 3 here. 14 by 3. 14 by 3 minus of 3k by 7 by 3 should be equated to 0. When this is equated to 0, this is what you have. So now equate this 14 by 3 minus 3k to 0. You have this condition. So what will happen then? Then 3k will become 14 by 3, then k will become 14 by 9. So when this k is 14 by 9, you have this as 0. So now auxiliary equation is this. Now what is the summary of the thing here? If the value of k is this, it is stable. Correct? Why it is stable? No sign change. If the value of k is equal to 14 by 9, it is 0, 0, 0. It will become oscillatory. Can we find what is the roots of this? So is it not 7 by 3 s square is equal to minus 14 by 9. So does this go with this here? So this 7 will come here, and this, when you make this 7, this will become 2. Is this s square is equal to minus, so minus 2 by 3, correct? So this is s square is equal to minus 2 by 3. So can we find what is s then? Is it not the roots of s, is it not equal to plus or minus j under root of 2 by 3? This is what you have. So now, am I correct? It is 14 by 9 whole divided, okay, sorry, this 14 by 9 divided by 7 by 3 is equal to 0.66, which is nothing but 2 by 6 is 0. Oh, one mistake, it is 3 3s. I'll just simply cross multiply them. So it is 14 by 9 divided by 7 by 3. 7 by 3. You have it as, fine. Okay, what happened here? This is 7 2s. This 7 will come there, and this, okay, this, okay, let me just make this 3 here. This is 7 here, this will become 3. So now it is 6 by 21. 6 by, so let me rewrite this. So we are looking at s square, 7 by 3 s square is equal to minus 14 by 9. So s square, this will, s square is equal to minus 14 by 9 into 3 by 7. So this will become 3, this is now 2, this is s square is equal to minus 2 by 3, minus 2 by 3. So what I have is okay, that's what you have here. Let me just go back. So this is Now if the value of k is 14 by 9, the value of k is, the value of k is 14 by 9, if the value of k is 14 by 9, so then this will end up with 0 0 0, then system is oscillatory. The system is oscillatory, you have a auxiliary equation. That's what is this, the roots are, you have plus or minus of j root 2 by 3, root 2 by 3. So what is this root 2 by 3 you have? So now this is actually under root of 2 by 3, which is now plus or minus j 0.816. So system will be stable if the value of k is less than 14 by 9. If it is equal to 14 by 9, it is oscillatory at a frequency of 0.816 radian per second. If it is more than 14.9, then the system is unstable. So you have the value of k should be less than or equal to 14 by 9. So if it is less than or equal to 14 by 9, system is stable. If it is more than 14 by 9, then system is unstable. If it is equal to 14 by 9, then it is oscillatory. It's oscillated at a frequency of this. So it takes to identify when does this particular column or the element of the first column becomes negative or positive. So then you just play around that. Let us do one more. So let us see this, what happens. This cube is square. Let us fill. It is 1 k plus 2. This is 3k. This is 4. Then it is s over 1, which is nothing but 3k into k plus 2 minus of 4 by 3k, and then it is of course here it is 0 0 means this will be 0 0, and then it is s over 0 means this into this minus this, and this will be 4 0 0. Now we have to find out 3k into k plus 2 minus 4 is equal to 0. When does this will become 0? Is it not a 3k square plus 6k minus 4 is equal to 0? Let us find the roots of this. For what positive values of k, this will become 0. So now the roots are, let me just find, it is 1, it's 2 degree, now it is 3, 6 minus 4. So is it actually 0.52 is one value. What is the other value? Other value is minus 2.52. So there are two values of k at which this will become so and so. So let us consider only the positive value. So this is a positive value. If the value of k is equal to 0.52, suppose if you make this 0.52, then you can see 3 into 0.52 multiplied by 0.52 into or plus 2 will be equal to just a verification. So now it is 0.52 into 3 multiplied by 0.52 plus 2 will be almost equal to 4. Of course this will be 4 if you just consider the higher decimal points. So then this will become 0. So for system to be stable, k value has to be greater than 0.52. Why? If it is less than 0.52, then this minus 4 takes a upper hand, this will become negative. For system to be stable, k should be greater than 0.52. If k is equal to 0.52, so this is the condition for stable. If the value of k is less than 0.52, then it is unstable. So why it is unstable? because you're going to have negative sign. So negative sign means you're going to have two sign changes, system is unstable, or two roots come to the right hand side of the S-plane. If k is equal to 0.52, let us see what happens. So will it become 0? So this becomes 0, 0, 0. Then you have the auxiliary equation. What is AFS? AFS is equal to 3ks square plus 4 equal to 0. So this k, I will call it as k margin. So k margin is how much? This is call it as k margin, which is value of k responsible for making the entire row 0, 0, 0. So that is marginally stable or oscillatory system. So now shall I write it as, what is a square now? Is a square is equal to minus 4 divided by 3k margin. So what is this now? Is it not minus 4 divided by 3 into 0.52? So is it now minus 2.56? What is S now? It is plus or minus j root 2.56, which is nothing but, what is the root of 2.56? It's actually 1.6. So plus or minus j 1.6 is the pole position if the value of k is 0.5. That means the poles will be on the left hand side if k is greater than 0.52. This is greater than. If it is equal to 0.52, where are the poles? Poles are at plus j 1.6 and minus j 1.6. If the poles are, if the value of k is, less than 0.52, then of course this will become negative. When this becomes negative, for k less than 0.52, you will have two coming onto, or two closed loop poles coming onto right hand side. So system is unstable for this value of k. So k margin is 0.52. If this is the value of k, system is oscillatory at this frequency. So let us take this one. If you consider this, I can actually find out what is, we are supposed to find out the characteristic equation from a given GFS into HFS. So we know that CFS by RFS is GFS by 1 plus GFS into HFS. If you equate the numerator to 0, that will be my characteristic equation. So now you have GS, you have HFS, so make that this into this and 1 plus. Is it not now 1 plus k into S plus 13 by S into S plus 3, S plus 7 into 1 is equal to 0. So now can I take the LCM and write it as S into S plus 3 into S plus 7 plus k into S plus 13 whole divided by S into S plus 3 into S plus 7 equal to 0. When you are equating this to 0, this will go off. So we have this as the characteristic equation. So what is the characteristic equation now? Del of S is equal to S into S plus 3, S plus 7 plus k into S plus 13 equal to 0. So we need to solve for this. So upon solving, is it not becoming S square plus 10s plus 21 plus ks plus 13? Is it not s cube plus 10s square plus 21s plus ks plus 13 equal to 0? So let us make, you have a coefficient of ss 21 and k. So now the equation becomes, so let us rewrite the equation somewhere here and then try to find out what is, we'll write it here, s cube plus 10s square plus 21 plus k into s plus 13 equal to 0. So this is my characteristic equation. So let me rewrite that here. It is s cube plus 10s square plus 21 plus ks plus 13 13 equal to 0. 13 equal to 0. Now shall we write the roots array? It is s cube, a square, it is 1, 21 plus k, this is 10, 13. So what is s power 1? Is it not 10 into 21 plus k minus 13 by 10? Then is it 0? What is s power 0? Is it now 13, 0? So now we have a condition where, okay, now 210 plus 10k by 10 minus 13 should be equated to 0. So what is then, for what value this becomes? So is it not 197, because 210 minus 13 is 197 plus 10k is equal to 0. So then what is k margin then? K margin is, so if you find the k margin, so what happens to your k margin? K margin happens to be, so minus 19.7. If you find this k margin is minus 19.7, what does indicate? For all values of k greater than 0, this is giving a positive value. So system is stable for any value of k greater than 0. So see here, my k margin has become negative. So because your k will never be less than 0. So when k is always greater than 0, that is positive number. For all values of k which is positive greater than 0, this is always be positive. This will always be positive. Even if you make k equal to 0, can you see it is 210 minus 13. So is the system stable? Because you have positive, 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 positive. So this is a stable system. For all values of k greater than 0, system is stable. System is stable. Okay, maybe you can try this problem. I think I have one more such problem. You can just try this. We'll see it in the next video. Thank you.